viewers, welcome to another class of Gyanan powered by Wishbag. Today we are in the second segment of energy band. So let's begin. The electrons in the outermost shells of atoms interacts when the atoms comes close to each other and when the energy of electrons in a single orbit splits into different energy level, an energy band is formed. This band structure will help you understand the splitting of an energy state into a band of allowed energy levels. As we decrease the interatomic distance of atoms, the quantized energy levels of the electrons in the outermost orbit comes closer and starts to interact with the other atom. And the resultant of interaction of electrons is splitting of energy level that tends to increase as we decrease the interatomic distance. At this point, R0, which is the equilibrium interatomic distance, observe the band of energies, and this shaded region is also called allowed energy state. And in this region, the probability of finding electron is very high. Now consider this figure, where atoms in a crystal containing electrons up to n is equal to 3 energy level. When the atoms are not so close to each other as they cannot interact with the other atom, the electrons in the outermost cells maintains their discrete energies. Now consider the same atoms, but they are close to each other this time. When the atoms are very close to each other, first the electrons from orbit n is equal to 3 starts interacting. As a result, the wave function of electron energy overlap and the energy level splits into bands of energies. As we continue decreasing the interatomic distance, the electrons from n is equal to 2 energy level may start to interact and the individual energy level overlaps and splits into bands of energies. As we bring the atoms really close to each other, that is, if the interatomic distance becomes very less, then the electrons from the inner shell n is equal to 1 may start to interact. In the above diagram, R0 is the equilibrium of interatomic distance. Now, we will describe the actual splitting of energy level of electrons in a crystal. First, consider an isolated silicon atom shown in the figure. A silicon atom has total of 14 electrons. The atomic configuration is 1s2, 2s2, 2p6, 3s2, 3p2. To understand it, we will discuss elaborately about the outermost orbit, that is n is equal to 3. The outermost orbit has 2 3s and 2 3p electrons. Therefore, the valence shell contains 4 electrons which are loosely bound and interacts with the adjacent atoms. 3s quantum state can occupy 2 electrons. Pauli's exclusion principle says that no 2 electron can have same quantum energy state. Similarly, in 3p state, 2 electrons can occupy any 2 states between 6 possible energy state. If we take n number of silicon atoms, then atomic interaction occurred between number 1, 2n electrons of 3s state which holds total 2n state. Number 2, 2n electrons of 3p state which hold total 6n state. Continuous decreasing the interatomic distance results in further interaction between split energy levels at the equilibrium of interatomic distance A0 and creates 2 bands where each has 4n quantum state. At absolute zero temperature, an electron occupies the lower energy state which is called the valence band, which contains 4n electrons, and the upper energy state is called the conduction band, which does not contain any electron initially. Here, Eg is the band gap and has a value of 1.12 eV, that is, the gap between conduction and valence band. If sufficient energy is applied to the silicon metal, then electron from valence band cross the band gap and reaches to the conduction band. The basic gyan about an energy band is that it is a range of electron energy in a solid, which is so dense with electron states that it appears to be continuous. With this, we have come to an end of this video. Let us take a quick look on what all we have learned so far. Origin of energy band formation in solids, splitting of an energy state, interatomic distance, electrons configuration of an isolated silicon atom, allowed and forbidden energy bands, valence band, conduction band, and band gap. So viewers, that's all for this video, and we will meet again on another lecture where we will discuss further on this topic. Till then, keep learning and keep watching Gyan on Classes. Thank you and bye.